Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link on the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by Adam Meakin, The Plain Truth, Ranty Flat Earth, Jose, Chocolate Saying, and Arwin. Good to have you all.
Good afternoon.
Good afternoon, everybody.
You got a full
Hello. What?
Hello.
Good morning.
Okay, so I know a couple of the guests are on specifically to answer one of their housekeeping questions. So when it gets to it, gentlemen, feel free to pipe up. Any signs of curvature?
Nope.
No.
I have to say, soundly still his name ring the bells everywhere. Everybody mentioned curvature, so I guess. I mean, I'm not saying that's the one I accept, but I say many people accept soundly bendy bridge as proof of curvature.
Right. We had Thomas Sheridan made a video specifically citing a compilation of soundly observations, and the title just was like red rag to a bull because it specifically said something like, just because a scientific theory's got problems doesn't make it wrong. And I was like, scientific theory, you say? And then he went on to talk about technology and models. So I set him straight in the comments and linked a few videos to dispute the video he linked, as I say, that was a compilation of a load of soundly clips. So he's observing an optical phenomena and saying, science! It's like, no, that's step one in the scientific method, Mr. Sheridan. Step two would be to formulate a hypothesis with both an alternative and a null. The null being the zero difference result, once you manipulate your independent variable, presumed cause of the effect, and an alternative, i.e. a confirmation that your presumed cause does cause the effect when you go forward to perform an experiment and validate or invalidate your hypothesis. Anyway, none of that was occurring in the Soundly video, which was referenced with the title that said scientific theory in it. So, like I say, red rag to a bull. I spent a good hour making a comment for him, which probably got deleted in half a second. But there we go, it made me feel better. So, any signs of axial rotation of the Earth-based variety, as we've got Ranty on?
No.
No.
Nope.
Any signs that you can have a gas pressure without a container, for all those space believers out there?
No. When I fart, it's definitely inside a container until I release it.
That's beautiful, Ranty.
Chocolate answered the question with one word. What was that, Chocolate?
The magic word is gravity.
Can't do it.
What was the magic word?
Even by their own standards.
Magic word is gravity, he said.
Oh, gravity. Excellent segue.
Can't work.
Any scientific evidence of gravity?
No.
Nah, that's why it's a magic word.
Yeah, but even in their theoretical gravity, it can't work.
What about the distance to the sun? Any evidence of that?
We'll have none.
Trigonometry.
Oh, we're getting to our Jose. Hold your horses.
Sorry.
Great,
No.
no.
Distance to the
not,
sun?
Nathan.
Anybody? Anybody at all?
No. Still waiting on Neil deGrasse to prove it.
Okay, what about a self-perpetuating molten iron core at the centre of a presupposed spherical Earth? Any evidence of that?
Afraid not.
Not a sausage.
Right,
I don't
Jose.
even know what lava is.
Say again, lava, I heard. I've got a terrible cold, I can hardly hear anything. Say again, Arwin.
Well, I would almost suggest adding what causes lava. So,
But who cares?
I care.
Ah, that's nice. What about the R value? Any evidence of that as it's directly and specifically related to the shape of the Earth and its flatness? Earth
Nah.
radius, gentlemen?
You only have to
I think-
presuppose it, and everything will be alright.
I think we would actually need a sphere for that. Being that we don't have one, we don't have radius.
But you
No,
can
We
imagine
can do
it to be.
calculations with it, but we've got no evidence of it.
Just the presupposition, eh?
Yeah.
Radius Dominus Gravitas Spiritus Sanctus Arwin. Go in peace, globeheads. In R you trust. Now I know a couple of you have done a presentation, Ranty and Adam. Do you want to get straight
Yeah.
into that?
I think Ranty's done the presentation, hasn't he? I've done a
You're
bit
here
of
for
it always.
support, I know, so do you want to kick off with that, Ranty?
Oh no, I think we're having it the other way around first, aren't we?
Yeah, we're going to bore people with the maths first. Otherwise, people will run away when I start. I don't know if you can share for me, Nathan, the spreadsheet.
Well,
Or
yeah,
if
if Ranty
anything
wants to
can-
get it up. I mean, I would say just go from the top. I'll give you a running start. So, as I understand this, Miles Davis has offered up his channel and his allegiance to flat Earth if somebody can prove that it's possible to make his photograph that he's taken from a series of images from a video on a compact camera whilst out shooting with some other much more sophisticated cameras. But the single shot taken from this compact camera video, he asserts cannot work on a flat plane. And if somebody can prove that it can, then he is going to swear his allegiance to flat Earth and delete all of the content on his channel. So this sparked the interest of Ranty, Anthony, and indeed Adam. So from there, who wants to take it away? I've got your spreadsheet up on screen now, Adam.
Yeah, brilliant. If we're doing that, then, and I'll quickly run through that, because I think, like I say, Ranty stuff then follows on a lot better.
Kill him, Adam.
This. So if we're looking at what I've done there, what I've kind of done is from Miles's video, taken the heights and distances that have been stated by him, and kind of applied the angular size calculator to it, so as to just match it up, see if it works. So I did that, and now obviously the angular size calculator is on a premise that you're observing across a flat plane, so no adjustment needs to be made for our results. However, if we are going to do angular size and consider that the observation is occurring from a specific point on a ball, then these height and distance measurements need to be taken into account, and there's actually a hell of a lot of maths and readjustments you can do in terms of line of sight distance. But for the purposes of this, all I've done here is use the target hidden and subtracted that away from the actual stated height. So you can see that the bridge, actually you can see all the bottom of the bridge, so its relative height stays the same. But with the target hidden values on the other peaks, I've then subtracted them away to give us the new relative height as it would appear when viewed from a specific point on a ball. Because obviously the further away that peak is, the more curvature it's subject to, and therefore the more reduction in its actual height will occur.
So if I summarise what you've just said, basically what you're doing is you're taking the calculations for the sphere Earth, which is an orthographic calculation, which doesn't perform a viewing function, and you're translating it into an actual viewing function by taking the angular size of any given item in the distance, i.e. the size it reduces to given the distance that you are away from it, and then factoring in the drop that would be relevant to that angular size when it's viewed over a curve, and then reducing that off what you'd have left in terms of the overall angular size, which you've then put into this spreadsheet. Is that correct?
Succinctly described, Nathan. Thank you. Yeah. So we've done that, and there is a little bit more analysis and inference we can draw from that, but I want to do a little bit more statistical work on that. But the first and most obvious thing is when you actually look at these angular sizes and their relationships to each other in the picture, you'll see that the ball angular size looks a little skewed. But rather than go into too much analysis, what I thought would be probably the best thing would be to rank them in terms of highest to lowest. This way, it's an indicator as opposed to anything overly accurate. But with the inaccuracies that are in Miles's photo, it's hard to do anyway. There appears to me to be a slight issue with regards to how the photo has been set up, and I do think that the camera is slightly angled up, and that's kind of borne out of the first set of ranking results. And basically, as I did the results, if you look at the green column and the blue column, from the picture, I just kind of ranked them from the smallest going down up to the largest. So C being Cairnock Hill Bridge, Strong End, D, E, and M. Relatively, they're getting higher as we go down. Now, when I compare that to the angular sizes, actually, that's an absolute perfect match with what's observed in reality, with the exception that the bridge and the Cairnock Hill are actually the other way round in terms of height with regards to angular size calculation. And I do think that this is, and Ranty will probably go into much bigger detail and explain why visually, but I do think this is because actually I think the observation is occurring at less than 210 meters, and we're getting a slight angling up, which will place the Cairnock Hill visually slightly lower than the top height of the bridge. Now, that being said, if we then compare the rankings of them all after that, you can see that actually it's an exact match. It's S, D, E, M in terms of the peaks, and they match perfectly. So the angular size calculation is in agreement with the observation. Now, when I then do the same rankings on the adjusted ball heights, we actually get a very strange result, very, very strange. There is actually no correlation whatsoever with any of them, with the exception of peak M, Meikle Bin, on all of them, actual observed and angular. Sorry, actual height is slightly, it's the second highest, but observed height, angular size height, and angular size on the ball, M is the only one that the angular size ball figures actually comes out to in agreement with the others.
So
and
just
actually,
to summarise,
yeah.
just to summarise what you've just stated.
No,
so with the exception of, I can never say it, Meikle Bin, I think I'll butcher it, doesn't matter. With the exception of that, when you take the 90-degree side-on orthographic view, however you want to describe it, the one that was presented in Miles Davis's video, the side-on view, where you can see both the observer and the target, or targets in this instance. When you take that and translate it back into the observer view and account for the angular size reduction over distance and the drop, and then factor that back into this table, nothing matches the observation in terms of where the maths would predict these things would be if you were viewing them over a curved surface. As opposed to, with the flat Earth observation, they all match with one strange exception, the one coincidentally highlighted by Miles Davis in the video itself. Now, it's asserted by Adam so far that it's because he believes that it's because the observation is actually lower than is quoted. Is that correct?
Yeah, lower, and also conversely, the camera, from my looking at my.
Oh, he's popped himself on pause. He's still there?
It would appear the camera's angled up as well. But yeah, the observed height and the angular size calculated on a flat plane, the relative rankings of where the peaks should appear in terms of height to each other matches up between the observed and angular size. However, when we go to the ball figures, it's exceptionally skewed. To the point that I'll just summarize it. There's between peaks B and S, angular size is in agreement that S is higher than the bridge, but actually on the ball, the bridge should be significantly higher than peak S. D should be higher than the bridge in both observed height and angular size, but on the ball mass, because the way it falls away, again, the bridge should be higher than peak D. M should be significantly higher than the bridge, which it is, both observed and in angular size figures. But in this case, this actually one is correct. It has predicted that M would be bigger than the bridge, but only by one ranking place. So it's basically, once you put these figures onto a ball and apply them to the image, there is absolutely no correlation between the calculated angular sizes and the observed image from a ball. However, we have a perfect correlation with angular size when applied on a flat plane.
Perfect. Thank you very much, Adam. So, Ranty, it's actually your screen I've got displayed to have this spreadsheet up, so I don't know if you want to follow on from there.
Okay. Yeah, sure. Just let me something prepared. So
very nice work, Adam.
Yeah, very nice, very well done.
Yeah,
and to be fair, I mean, I had to do no work apart from just put some pretty pictures together. So it's all down to Adam. This, he gets all the credit for the work that he's done.
Teamwork, dudes. Teamwork.
So this is the impossible, if it's the impossible image on a flat Earth, apparently, according to Miles Davis. Now, the criteria for him removing all his content from his channel and becoming a flat earther is that if we can demonstrate that these series of images that he's posted are consistent with can be proven to be produced on a flat Earth, then this is the criteria that we need to address. And as long as we meet this criteria, then he will do as he said, which is remove all his content and become a flat earther. So Adam's already told you how it's possible. I'm going to show you a few images now to show you exactly what he was talking about. Essentially, for this presentation, I'm going to assume that he is at 210 meters. I'm going to take his word for it. I know it's in disagreement with what Adam says, but we can work around that. And we have Miles's camera height of exactly 210 meters above sea level, and is exactly the same height as the bridge. So here's the bridge that he's looking at. He has a direct line of sight to it. In the next image, we will have an angle that is produced, and this is the angular size. So this angle from the top of the bridge to the bottom of the bridge, given the distances involved, will create an arc angle, which we can measure. And this angle is 0.26738. I can show you that on how to work this out on a calculator. So if I come up to the angular size calculator up here, and we go for working out the angle, and we need to put the distances involved, which in this case was 45,000 to the bridge and a height of 210, and we calculate it, it can give you a degree. So there's the degree that it gives you. So this is how you work it out using trigonometry. 0.26738. That is the degree. Anyone can use this. They can put the distances involved. They can check the workings out. It's all there to be done. On the next slide, essentially, this is what it means.
Can I just stick a bit of clarity in on that one? I mean, the numbers that are coming out are obviously very, very low, and you look at the image that Miles presented. This is obviously to do with regards to viewing by the eye. However, they're all scalable, and obviously with Miles's images, they're zoomed in, but the reality is the ratio of the scale of the angle of it would be the same. So it's just, obviously, if somebody looks at it straight away, 0.2 degree isn't marrying up to any of those images, but it's the relative ratios that's important on that, because you've got a zoom and a etc. on that.
So an angular size greater than 0.26738, which is this ratio here. So an angle of that greater than that will make the object appear higher than the bridge. So if we have something in the distance and this angle is higher than 0.26738, it should appear bigger than the bridge. If it has a lower angle, it should appear lower. It's pretty basic stuff. So here we have a target in the distance. So this is the target, the hill in the distance. And now we have a new arc here. And we have a new angle produced from the observer looking to the top of the mountain and the bottom of the mountain. We now have a new angle. And dependent on what that angle is where it would appear to the observer in relation to the image produced. So if it's like I say, if it going back to this, if it has a higher than 0.26738, it will appear above the bridge. And if it's a lower arc, it will appear below the bridge. Here we have, this is Miles's own workings out. So here I take a screenshot from his channel. This is the image that he wants us to work with. He's got the details of certain mountains in the background and a nice dotted line across the middle to denote his 210 meter to the bridge. So this is his eye line, direct line of sight. So this is where we can work from using Miles's own evidence. Next image, not really that important. This one is though. I've put a little ruler in. Now it doesn't really matter too much. This is just so that you can get a rough idea for a 0.276. So 0.2767 or 76, whichever it is. We have a ruler in now to the arc degree. The next image, this is looking for Mikhail bin. So the angular size of Mikhail bin on a flat Earth is 0.35, which is substantially higher than 0.26, which is this dotted line. The angular size for Mikhail bin on the ball Earth is 0.27, which is just 0.1 of a marking above this dotted line. So when we scroll in and we look how small 0.1 of a marking is, it's literally right above this red line. So if it's a ball Earth proof, this Mikhail bin here should be right above that line. If it's a flat Earth proof, it should be much higher, much nearer to 0.35. And as you can see, Mikhail bin is substantially higher than this dotted line. Now, you can't make mountains get higher in the distance because obviously if it's fallen beyond the curvature of the Earth, it's now down to essentially the same height as this 210 meter bridge in the foreground by virtue of its angular size. The fact that it is substantially higher than this dotted line makes it more of a flat Earth proof than a ball Earth proof. And I can show you that on the next slide I've put a white line in across the top of the hill. And if we scroll into the calculation, we're coming out roughly at 3.4 degrees as an angular size, which is much more consistent for a flat Earth than it is for the ball Earth. The next image is for Stone End. And again, we have this dotted line that Miles has conveniently put across the middle. Put the ruler in again just to give you a sort of visual. Here we have on a flat Earth versus a ball Earth, right? So angular size Stone End on a flat Earth is 0.30, which would be this line up here. And for the ball Earth, it would be below the red line. Now, the fact that we can see all of that mountain above this line says to me that this strong end has not gone beyond the curvature of the Earth. It hasn't grown by 0.4 of a degree in angular size. However, you can actually lose some things from the top of mountains if it's in sort of fog, mist, clouds, anything like that. One thing you can't do is make the mountain grow. So again, I'm going to say it's more of a flat Earth proof than a ball Earth proof, because it certainly doesn't match up to it falling beyond the curvature of the Earth. Its angular size is not related at all. Lastly, we go on to Dunbreak and Earl's Seat. Both appear in the image at an angular size of 0.269, which is essentially this white line. So basically, where he's put these two arrows in here, this is the line of sight, and I've put a white line in that shows you that. That's where they appear. Let's go on to the next slide. Sorry. Both appear. There we go. So in the ball Earth model, this is the white line. This white line should be where it appears in the ball Earth model. This is 2.1 degrees. This is how it should appear. These Dunbrack and Earl's Seat, if you put their angular size in on a ball Earth, they should be at 2.1 degrees, which would be where this line is here. And again, they are substantially higher in reality as opposed to what the image shows. So,
I did a bit of stats on that as well, actually, Ranty. So I took the percentage variance, so away from where it should be. And actually, other than the bridge, which we're assuming is kind of your reference point, so that's got no figure. If we take from Kernock Hill, that's 29.1% variance of what it should be. Meikle Bin is 22% out. Earl's Seat is 33.7% out. Dunbrack 30.05 and Strong End 30.6. So
to summarise again, Adam, you're good at giving these figures, because what you're basically saying is the difference is massive. It's about a third out on the ball.
Yeah. Well, you can see here with these two white lines, this is the actual position. The top line is the actual position as evidenced in the image. The line underneath it, which is far down the scale, is where it should appear on a ball Earth. And you can work that out as a percentage. It's roughly, 25% difference. It's lost 25%, or it's grown 25% in height. Much clearer to a flat Earth proof than a ball Earth proof.
It's not. It's worse than that. It's an actual impossibility, given ball topography, for these peaks to be there. But the only way in which you could get this image would be to have multiple variant levels of lumen and refraction occurring to bring the peaks into what would appear to be representative of positioning on a flat plane. But there is no way in which these peaks could ever sit relative to each other as they are doing on a ball.
But his claim,
and that's the point in the first column. They just can't be like that, because they only represent relative to each other like that on a flat plane. As soon as you apply the relative distances for all these different height peaks, which are different distances from the observer, the level of curve that's applied to each one is massively different, to the point that the biggest peak is smaller than the second biggest peak when viewed. So it's, to me, what Miles has provided is a definitive proof, that this view, this observation is not achievable on a ball, because of the way he's presented all the other heights and gave us all that quality detail. The only way which you can marry up this observation is when you apply these peaks to be positioned on a flat plane. It's impossible on a ball. It's impossible.
It's impossible on a ball, and confirms we live on a flat plane when you take into account perspective. So unfortunately for Miles, either he doesn't watch the show or he doesn't pay very much attention, because when he presented this, he did all the mathematics in an orthographic view using the begging the question, proof of nothing, perspective hijacking curve calculator. And all we've done is taken that mathematics and applied angular size reductions, which aren't included, because as Rumpus pointed out, the curve calculator is not performing viewing functionality.
And the angular size calculator takes this into consideration when it looks from the observer to the object. It gives you an angular size, something that you can actually work with. And that's represented in very small degrees, but they are measurable, and they can place objects in the distance at relative heights to the other objects that you're looking at. So you can, some will be higher, some will be lower. They may be bigger in actual size, but in relative size to the observer, they can be smaller or higher or the same height. And this is why when we use angular size calculator, we can prove once and for all that Miles now needs to remove all his content from his channel and become a flat earther.
Yeah. And we're happy to help him along some evenings, get him up to speed a little bit whenever Miles is ready to. Rumpus is disagreeing with us.
Is that the end of your? Is that the end of your presentation?
That's all we have. That's all we need.
Excellent.
We don't need any more.
Job well done. Thank you very much, Ranty. Thank you very much, Adam.
Pleasure.
Well, we should be expecting a channel deletion then, correct?
Indeed. Well, all this content removed at least. This was the claim. We needed to show that it could be achievable on a flat Earth, and that's what we have done. We have proved conclusively that the image does marry up to a flat Earth by virtue of using its angular size. We've met the conditions for that. The fact that we've debunked his entire video and arguments about it being a ball Earth proof is just secondary. We met his criteria before when we showed how these relative heights should appear in relation to the bridges, etc. And yeah, so looking forward to him. Well, do we actually want him as a flat earther, though? Would we actually want him as a flat earther?
Well, this is his declaration, not ours. It's not like we're requesting him.
Yeah, we don't have to go for a pint with him. We just want him to make a statement that it's flat.
I don't know. Anthony's pretty keen. He was like, "I'll buy you first pint as a flat earther. No worries." But he's apparently skulking around St. Bees when Ranty and Anthony met Al K.
He probably was. He didn't have the courage to come and say hello, though. We'd have bought him a sandwich just like we did Al K.
Yeah, with a bit of love.
I'm
bit of love in it. Hello, Anon. How you doing?
Hello. How you doing?
Good to have you.
Hey, I made a song after watching this.
Hang on, I just want to address the rumpus here. The rumpus, it doesn't matter. We're not talking about the ruler. The ruler was just there as a guide. It was not a specific, this is the angle that we need to be taking things from. However, the rumpus, we did need to know exactly where each individual mountain would be in relation to the height of the bridge. That was the most important thing. The most important. And when you look at that Mikhail Hill, that thing is above, way, way, way higher than the height of the bridge. And that completely destroys the observation from Miles, regardless of what you think. Everything else matched up perfectly to a flat Earth. Forget the ruler. Don't focus on that. That had nothing to do with the presentation. That was
well, just to back that away, easy enough. So he says you've used the ruler to determine the angular size. Wrong. The ruler is being used as a visual demonstration. The angular size was determined by Adam and presented on a spreadsheet. If you would like to compare using mathematical number-based evidence rather than a graphical depiction using a very crude ruler for scale, then you're welcome to check out the spreadsheet that was at the beginning of the presentation.
Yeah, the mass was there. The picture was sort of the little ruler thing there was just to exemplify the point so that you could see the differentials between the line that Miles had drawn on. I thought it was quite a clever way of doing it, but probably Rumpus, if you go back and watch it again, and there is the replay show, so maybe if you slow the speed down a little bit, listen carefully, you might grasp it instead of coming in with daft questions that just show a level of ignorance and lack of understanding, mate.
Okay, the rumpus says the maths is gibberish. Why is the maths gibberish? We've just used trigonometry, which is mathematics. We've used trigonometry to prove the angular size of the objects we would be looking at in the distance and their relative heights to the observer. How is that gibberish?
It isn't. There's nothing wrong with what Adam did. Kudos, Adam.
Oh, apparently we don't understand trigonometry. We don't know how to plug things
whatever.
into the trigonometry calculator.
I think you can stop reading his comments at that point.
Okay.
So Miles Davis haven't been watching this episode of the Flat Earth debate because the channel, I was just checking and the channel is still up. He should delete it, right?
Well, I don't know what he's agreed to. I haven't even watched the video, to be perfectly honest. So maybe Ranty can give us a summary of what was actually promised.
Well, the promise was that if we could demonstrate that the image that he produced could be achieved on a flat Earth, then he would remove all his content and become a flat earther. That was the standards with which we needed to prove. In order for him to do that, we needed to have these conditions met. So I think we've met those conditions. We've showed that yes, it can be. This image does in fact work on a flat Earth. So we've already way past that. The fact that we debunked his entire video is, like I say, it's a secondary plus point, because I think we should be using this sort of work from him much more. In fact, it's, in my opinion, it's probably in the top 5 of the best flat Earth proofs of the year. It's really good.
If anything, it is one of the best flat Earth proofs of the year. I mean,
Yes.
It can only work on a flat plane.
Yeah, I mean, it's great that he actually got to exactly 210 meters. He went to the point of making sure that we all know that he was exactly at 210. The bridge was 210, and then we could work everything else out. And thanks to him,
Hold
now
on,
have
hold
this
on.
as a
You
solid
don't need
flat
the.
Earth proof.
Let's keep it concise. Let's not have the sarcasm. So just point out your grievances rather than be sarcastic.
I don't have any grievances. I mean, I wouldn't have even known his work was still around. I mean, I thought he disappeared months ago, but it was Anthony that mentioned it and said that he was back on the scene and he had this evidence that destroys the flat Earth, and but he was willing to put his channel up for it. So that's when we looked into it, and Adam knocked it out of the park with his mathematics.
I mean, I know Rumpus is saying that the maths is wrong there. We've not gone and taken these things. We've only used what the current academic world says is correct. We've applied the figures that Miles has stated to that to make a conclusion based on what he was stating and to analyse those figures. So, Rumpus, mate, we're not cooking out. We're using your academic way of calculating things, and the numbers have been put in. And unless you're going to show a different way, mate, that you only need to include perspective when determining angular side. What a doofus. Do you know what I mean? The numbers are there, and the numbers speak for themselves with regards to the assumptions that Miles Davis made. And for me, it's quite clear that, unfortunately, with the distances and the heights, there is absolutely no way when you apply those numbers onto a globe that you can get the image that is taken from reality. And in fact, when we bothered to put the angular size in, we see such a beautiful correlation between the image we see and how it should be laid out proportionally on a flat plane. To me, that's the one that meets the criteria that Miles was asking for, that it wasn't just a matter of disproving it on a ball, but proving that it could work on a flat plane. To me, it's that bit of maths that really does show that it is only achievable and does work on a flat plane. That means that Miles should be a man of his word and take his channel down, I'm afraid.
I'm wondering if any of the ballers in the chat and listening live to the show either agree or disagree with this debunking and want to jump in the panel and give us their take on it.
Rumpus says he's going to do it. You'd have thought he'd have already prepared it and passed it to Miles by now, wouldn't you, really, if it's that simple? But don't the Rumpus do stuff, say he's going to do stuff and never do it anyway, so I won't worry. You're still waiting for that last lot, aren't you, from when Riley went to the beach?
Yeah, Arwen tends to keep tracks of those sorts of things. He's got a good memory for it. I don't care.
I would hold me breath then for Rumpus producing
Hold on,
something.
what? Sorry?
Oh, for something that Rumpus was supposed to do but didn't, you tend to
Oh, right.
you keep on top of that. I don't.
Well, he was supposed to model out how Riley's video view of the super close to the surface of the sea observation in long distance could be possible on a globe model. That's basically what he promised.
I
And
think
it's, of course, an astronomical job that he can do that.
Have
See,
you
he's
read
all
this?
bluster.
sorry, Nathan, you asked us to go into a bit more depth about why we thought it was a sensational flat Earth proof, and I think Adam went over that, but I'll just try and explain it a little bit differently. If I'm presenting, just let me know.
You are.
Okay, so I don't know exactly how Adam's figured it all out, but I know what he's trying to say. What he's trying to say is that when you look at, for instance, Cairnock Hill in the centre, and its relative position to the bridge is, say, just below the bridge, and yet Stron End is just below the bridge too. If it was a ball earth proof, some of these could be wiggled around. So Stron End may appear much lower in the image, and Cairnock Hill, by virtue of its position being slightly nearer to us, should be slightly higher. So this mountain range would look different, is what Adam's trying to say. If you put the same calculations into the ball, it wouldn't look like this. What we're looking at here, this mountain, all these mountain ranges wouldn't look like they are right now, but it works perfectly on a flat Earth. This is the model that you would expect it to look like on a flat plane, regardless of where it is in relation to the pole in the foreground. But if you input the data on a ball Earth, like Mikhail Bin would be far lower, and essentially you could even have Cairnock Hill higher than Mikhail Bin. It would just look different. The terrain would look different. And it doesn't. It matches much more to a flat Earth proof than a ball Earth proof. That's what he's trying to say.
Ranty, that's exactly it. I can list it for you. If both in the observed height you'd have the bridge and Cairnock Hill, it would then, both from the observed and flat plane observations, go in the order of Stron End, Dunbrack, Earl's Seat, and then Meikle Bin. When we apply the mathematics to the ball stuff, it comes out in terms of the Cairnock Hill being the smallest, then Stron End, then Earl's Seat, Dunbrack, then the bridge, and then Meikle Bin. And it's that complete jumbling, because what happens when you apply the curve calcs and the effect that the distance away has on the relative height, it jumbles up the relative order of the peaks. And it's that lack of correlation and the way it jumbles it up on the ball because of what the curve does, that's really is the big proof that it is not on a ball. And then say the subsequent proof is the correlation with just angular size and on a flat plane correlating with the observed. And it's that complete lack of rank ordering being the same between observed and angular size on a ball that is a real massive ball buster, I'm afraid.
Indeed.
Excellent.
Can I say something?
Sure.
I'm really amazed how low Rumpus can go, because in chat he actually doubled down on the promise about Riley's observations. And he's making excuses that he's had a terrible cold, but he's 98% done with his website about Riley's observations.
What's still about the Isle of Man, is it?
Yeah.
That's so last year.
Literally.
What a joke.
That's like writing a review for a film that was released 3 years ago.
You're on the panel. If you do want to talk to the chat, you feel welcome.
All right.
Just read out what you put. Go ahead.
Me?
Yeah, you're chatting it in the chat box. It's like, just say it. You're on the panel.
No, but that's literally what Rumpus said. It's a little bit up early in the chat. So that's just what he said.
He has nothing left, Rumpus. Nothing else to offer.
It's just amazing that after all this time, he still holds on to the claim.
You utter morons. Carnock Hill is 413 meters. The bridge is 410. Therefore, on a flat Earth, the hill has to be above the bridge. Really? Is that
Has he done
correct,
the angular
Adam?
size on that?
Sorry, say that again, Adam.
Has he done the angular size on that? If you look at just at the basic distances, the angular size for the hill is 0.275 degree, and the angular size from the bridge, because it's virtually twice as far away, is 0.26. Now, just using a little bit of like rule of thumb maths, you can see that it's 45 kilometers away and literally just short of double the distance. But if you double 210, it comes to 420, which is very close, look, to Carnock Hill, but it's slightly more. Okay? So what Ranty, there will always be some slight variances in these degrees, because as Ranty was saying, this is only taken into account angular size. It's not having any consideration for atmospheric optical effects, which could skew the observed results compared to the angular and show a small differential, which is why when I said what was important when I was analysing the data isn't to try and take the photo and apply precise numbers to it. It was important to just kind of take the rank ordering because that is sufficient to reject or accept flat or ball in terms of the positionings of the peaks.
So it's like analysing a waveform then. So if you had a wave form that you was able to look at, you could be able to match it up to the terrain that we see, and it follows the same contours on a flat Earth, but on a ball Earth it doesn't match at all. That waveform is different. That's why you can conclusively say that it's more of a flat Earth proof. Well, it is a flat Earth proof than a ball Earth.
Absolutely.
Yeah, the correlation between the rank ordering of the peaks is the same on the observed, the angular size calculated on a flat plane. It is not, and is completely scrambled when you do that, applied those angular sizes to the positioning on a ball. There is no correlation.
Rumpus is actually promising in chat that he's writing a full manual on how the observations work.
Sorry, I just don't want this to slide. I did read his comment, but that comment came almost immediately after Adam's question, which kind of drifted into his explanation. So Adam's question was, did you include the angular size when you threw out those numbers? Just want to ask Rumpus before that gets distracted away from I'm doing Isle of Man. Maybe if you can repeat and reiterate your question, Adam.
Sorry, could you just repeat? I just got quickly distracted there, mate.
No worries. I was saying that at the start when you interrupted, so I read out Rumpus's comment in regards to the 420 meters, and you said your first words were, "Does he include the angular size adjustment in that?"
Yeah, I'm lost. Maybe make the point for me, Nathan, and help me.
No, that's it. I'm not making a point. I'm asking a question to the Rumpus. When you threw out those numbers, did he also include the angular size adjustment, the whole point of what you have done, or did he just throw the numbers out there?
Okay, now he's talking about what? Okay, he's talking about relative heights, and the angular size is something you do after.
Right, is it?
Determine the absolute size. Right. Oh, that's interesting.
Nathan, can you share my screen just for a moment, please? I am going to... Right, Rumpus has basically said that if something is higher than you in the distance and you're looking straight out, it can't have a lower angular... a lower angle than you are, essentially. So let's start with this. So the 45,000 is to the bridge with a view height of 210, and we're calculating that comes out at 0.26 degrees, right? So if we double the distance, 900, so it goes to 90,000, and we almost double the size of it, and we put it at 400. So now that the object we're looking at is almost twice the height of the bridge, right? And then we calculate it. It comes out at a lesser degree, a lower degree. It's 0.25 as opposed to 0.26. So in the field of view that you're looking at it through, it will look smaller than the bridge, even though it is almost double the height. The Rumpus, you failed again, mate. Absolutely failed again. You can have things in the distance that are higher than you that will look lower in their field of view. The angular size will look lower than the bridge, something that's smaller in the foreground. Absolutely busted.
So I'm hoping Adam can reiterate the point, as he filled this in despite the fact Anthony and Ranty didn't pass all credit, or did pass all credit to Adam. They were certainly on the phone with me at 9 o'clock this morning talking about it, and have been since then till when the show started, and all of yesterday. So this is obviously not an obsession, but certainly a great interest to both of you. So certainly Adam doesn't get all the credit, but a vast chunk of it. Are you there, Adam?
Yeah, no, mate. It's listening to you guys chew. Like I say, it's the Flat Earth Collective, mate, that does these things. I'm listening to you guys chew yesterday. That then said to me, go ahead and do this bit of stats on it. And do you know what I mean? It's teamwork. It's teamwork. And it's the way forward, isn't it? But I just want to make one thing which just reiterates Ranty's point of view there. The bridge and Crannock Hill are, for all intensive purposes, the bridge is half the height of Crannock Hill. But Crannock Hill is twice as far away. And if you look at them, for all intensive purposes, they look the same height. One is half the size and half the distance away. And that's a great exemplar that just completely negates the point that Rumpus is trying to make to try and undermine what we've presented today. But before he could do so, he really has to say, well, actually, a bridge that's half the height and half the distance appears exactly the same as the hill. Unless he can undo that in terms of size and distance, then really the criticism he's applying to what we've presented has no validity.
Cool. And did you want to stress what you'd done in terms of your methodology, and then I'll round out this show?
So cryptic. The final, I suppose the final summary is it is impossible for the observation that we see to have the peak heights match up with the peak heights when laid on a supposed ball Earth of radius 6371 kilometers. The only topography that gives a correlation of peak size and distance is if we lay those peaks out on a flat plane.
Perfect. And with that, I'm going to say first and foremost a huge, massive thank you to all of the debating panel for making this debate possible. And if you were late to the show, this will get rebroadcast in about an hour's time on my second channel, which is Nathan Oakley. There's a link in the info box, so check that out if you didn't catch the first part of this show, or the evidence that demonstrates that Miles Davis's observation absolutely and only works on a flat plane. So also a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. And if you hated the show, you know exactly what to do. But if you liked it, maybe consider sharing it with a friend or subscribing if you've not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!